Right, good morning, ladies and gents. This is our week 8 online learning. Now, I'm very specifically happy today because by the time you're going to listen to this, which is really in a week time, the grade 12s and 7s are already going to be here. And I tell you what, guys, your time's going to come very, very soon. So hopefully, if everything goes well, and the first week of June, when you're listening to this, and the grade 12s are here in 7 and everything is still going all right, you guys are going to be back here, I reckon, in 2-3 weeks' time, by the end of June, hopefully. Anyway, we are carrying on with Euclidean geometry. We have spent a few lessons just revising stuff from grade 8. We carry on revising from grade 8. Last week we had a look at angles between lines, and we started solving some problems of two-dimensional shapes like triangles, quadrilaterals. We're going to carry on with quadrilaterals, okay? We're going to look at all the different kinds, and really where we're going, just to give you an idea, at the end or towards the second half of this week, we're going to look at congruency. Okay, so that's the new stuff, which is, I'll be honest with you, a bit more difficult than the stuff we've done last year. The name of the game, really, in Euclidean is to be very meticulous, to draw, to just remember all the terms, and to remember all the reasonings. Remember, it's all about reasoning. It's like being a lawyer. You can't say anything without actually putting some evidence behind you. And the evidence we use in Euclidean geometry is the properties. Okay, so we need to know the shapes. Now, by the way, everything I'm talking about is in page 145. And what I will do is look at all the different quadrilateral and just have a few seconds on each one of them. What you need to do, and this is really more important, this lesson is just to kind of get you started. What you really need to do, and this is your classwork, is to look at page 145 and really study that page. Spend time on it. You can copy it, you can read it, you can sing it if you want, you can decorate it, but you just need to somehow torch it, engrave it in your mind. Okay? I can talk about these things, but eventually you just got to remember all these different shapes. Okay, quadrilaterals. Quadrilaterals come from the word quad, which means four in Latin or Greek, whatever. Okay, so the first quadrilateral, to just give you an idea of a normal quadrilateral, this could be a normal quadrilateral. Okay? Anything with 4 lines. Okay? It's not very clear that there's 4 lines. Okay? But now this quadrilateral doesn't have any specific properties, so we're looking at specific quadrilaterals that, like families inside the big family of quadrilateral, and having a look at their properties. So the first one is a parallelogram. Okay? Parallelogram, like it sounds from the name, it has 2 pairs of parallel lines. This is parallel to that, and that's parallel to that. Okay? So usually we draw parallel like this. So we put a little arrow, and this is parallel to that. But apart from that, this whole side is equal to that side, that little line here, and that side is equal to that. This one is not equal to that, but opposite sides are equal. Okay? Same thing with the angles. Opposite angles are equal, opposite angles are equal. That's a parallelogram. Now, if we take a parallelogram and we restrict it, meaning not just this side is equal to that side, but sides, the neighboring sides are also equal, so that means all the sides are equal now. They're still parallel to each other, and the opposite angles are equal, but one more restriction, all sides are equal, then we call it a rhombus. So a rhombus is kind of like a perfect parallelogram. It's a parallelogram where all the sides are equal. Now if you take, again, the parallelogram, we're going back to the parallelogram, and we just straighten it up. So imagine taking this and just, you feel like, some OCD people feel like, why is it skewed? Just straighten it up. You get a rectangle. What does it mean, straighten up? It means that all the angles now are equal, and they're all 90 degrees. Okay, so this was not 90. Now they're all 90 degrees, right? Rectangle. Now you're taking that rectangle, and just like you took the parallelogram, you turn it into a rhombus. Now you're taking the rectangle where the sides are parallel, but only opposite sides are equal. And now you're squaring it, meaning you're making all the sides are equal. What do you get? Square. And a square is like your perfect quadrilateral. All sides are equal. All angles are 90 degrees. Okay? square. Now we forget about parallelogram and we just take quadrilateral where one pair of lines are parallel. So these two lines are not parallel, but these two are parallel. They're not equal to each other. There's no equal sides here, no equal angles, but these two lines are parallel. That's a trapezium. Okay. Now, where should I take this one? Okay, a kite. A kite is just a kite. Okay, so think about shape of a kite. That's exactly what we call a kite is. Okay, so what do we have with a kite? There's no parallel lines, but the neighboring sides are equal. So that's equal to that, and that is equal to that, and those two angles are equal. Not those two, okay, just like in a normal kite, but these two angles are equal. Okay, kite is kind of on its own, kite and trapezium. Right, I'll stop here. It is really important that you don't just listen to this video, you also read page 145. Read page 145. Take 10 minutes. You can copy it. It might be a good idea actually to just copy it into your book. At least draw these shapes, but you just got to know all the everything that is written. Okay, I just highlighted the most important thing, but there's probably a little bit more intricate details. Right, see you in the next lesson.